Okay, find the time for which the car is accelerating. Okay, let's think what's happening. Let's just do a little sketch of a velocity times graph. Just the first bit when it's accelerating. Where it's starting from rest. Okay, so it starts from rest and it has a constant acceleration, so straight line. There you go. And it reaches a speed of 25. So let's put that in. This is my V. This is my T. And we want to know the time. So we want to know the time there. Okay. Well, the distance is the area. Okay, so the area under a velocity times graph is the distance. So this is a distance of 200. So we can say the area of the triangle is 200. So that's half times the base, which is t, the time, times the height, which is 25, equals the area, which is the distance, 200. So solve for t. Okay, so we've got 25t equals 400. So t is 400 divided by 25, which is 16. Okay, part B, sketch of velocity times graph. Well, we've already done the first bit. Okay, the acceleration of the first 16 seconds. Okay, what happens after that? The car then travels at this speed for 400 meters. So we've got a constant speed of 25. So let's draw that in. Okay, it's only a sketch, so it doesn't have to be to scale. But we need to know what time that's going to be. Okay, well this is for 400 meters. So that means that the area of this rectangle is 400 meters. Okay, so we've got 25. 25 is the height times the time, the width, I'll call it the width, equals 400 meters. Okay, so the width, or the time, is 400 divided by 25, which is 16. Okay, so I'll put that in. So this time is 16, because the area of this rectangle wants to be 400, because the distance for the constant velocity is 400. So we put that in, and then it decelerates uniformly to rest over a period of 5 seconds. Okay, so this next bit is 5 seconds. And now it's going to decelerate, so it's going to be a straight line gradient going down. Okay, and that's going to be 5 seconds. So 32 plus 5 is 37. Okay, make sure you show the key bits. Okay, 32 seconds here, the end point 37, the 16 seconds here, the 25. Okay, the examiner's looking for all these points. Okay, so the examiner's going to check that coordinate's correct, that one and that one. Straight line, all straight lines. Okay, find the average speed of the car during its motion. Well, the average speed is the total distance over the total time. Well, the total distance is the total area under the graph. Okay, we've already got this area of 200 meters, area of that triangle. The area of this rectangle is 400, so all we need is the area of this triangle. And then the average speed is going to be total distance over total time. Well, the total time is 37. Okay, so average speed is the total distance, which is 200 plus 400 plus the area of that last triangle, which is half times base. Well, 32 to 37 is 5 seconds. The height of that triangle is 25. All divided by 37. Okay, which comes to 17.9 meters per second.